Hey everybody, this is Patrick again. Today I'll start to talk about expressions in Maya. So this is a beginner's introduction to expressions. So what are expressions? Expressions are lines of code or formulas or a phrase consisting of numbers to be evaluated, and these codes and lines of mathematical expressions will evaluate and give us a value which we will use to drive attributes in our objects. So it could be the number of sides of a triangle. That value could control the position, or maybe just x position of an object in space. It could control the rotation of another object. It could control the brightness of a color. It could control anything that can be controlled by a value. So let's start with the most basic kind of expression. I'm gonna create a cube. All these fields that can accept values as numbers can take in an expression. So let's say I want to move the cube along just the x-axis. What we can do is there are two ways to access the expression editor. One of the ways would be Windows, animation editors, and expression editor. That would bring out the expression editor for you. But my favorite way of doing that would be click translate X and select that channel and then expressions. Anyway, just get the expression editor, and the simplest form of expression that we can write is to give the value a constant. Okay, so whatever we just selected, Maya gives us the internal name that it recognizes, so which is p-cube1, which is the name of the object, dot translate x. So in this kind of notation, translate x is understood as an attribute to p-cube1. Okay, so since we're targeting this by selecting this and then going to expressions, our target object has now given us, Maya has now given us a name, which is pq1.translatex. So what the simplest thing that you can do is do pq1.translatex. Okay, note the capital letter, small letter, the lowercase translate, and the uppercase x. So lowercase and uppercase makes a difference to Maya, so be careful about that. So pq1.translatex equals to 1, and you can do create, and you can see that the cube has jumped to 1 unit in the x-axis. Okay, so it jumped 1 unit, and the next thing that we observe that happened would be translate x attribute is now colored, is now 1, and is now colored purple. So we know that if I set a key, it's colored red. If I set a connection via my connection editor, and I sort of, maybe I get translate, so let's say my translate x is driving rotate x, you would see a yellow coded, so that's a connection editor. Okay, so so a little bit off track here. Connection editor actually can use a translate value to drive a rotation. So that's another way we can use one value to drive another value, an attribute, without writing an expression. So we're not going to go to that for now. I'm just trying to show you the color coding. When you do a constraint, it will be green. Okay, so just note that when you have magenta or purple color, it is actually an expression. So I'm going to delete my animation and take away that connection now. So just now we used this value to drive the rotate, so now when we took it away, the value didn't go back to 0. So if we want to, we have to type it back. So when we play, nothing's happening because our expression, okay, so now to get back my expression with translate X selected, we go to expressions, and okay, it brings back that expression for us, which is p cube 1 dot translate X is equals to 1, and that doesn't change across the timeline, because at every frame this expression gets evaluated and it is a fixed constant, which is 1. So that doesn't change. If I put like 3, and then if I want to update that expression, I have to click edit. If I click elsewhere, and when I click this guy back, and I PQ1 translate X, and I want to see what's driving it, I get back my expression, which is 1, and it's not 3. So what we need to do is change that value and hit edit button, and it would go to 3 units and update. Okay, so be very careful. You don't want to write the whole chunk of stuff only to click away and then come back. It wasn't updated. So the next level of complexity in our expression that we can write would be translate X equals to frame. So frame is a special name in expression language that takes the frame number. Okay, so if we hit edit, you would see that at frame 1 translate X is 1. So if we increase that by step forward 1 frame, you would see that translate X is 2, and then so on and so forth. Therefore, when I zoom out and when I play my timeline, you would see a moving cube. Okay, so far so good, right? So what are we driving now? We are using a value which is read from the timeline and processed at every frame. Okay, and that value changes, and in turn that drives the translate X. At this point, I'm free to do a translate Y instead, but note the uppercase. So if I hit edit, you would see that as I scrub the timeline, translate Y now listens to and reads from the current frame of the timeline. So there's nothing to stop us from doing translate X is equals to frame and translate Y is equal to frame 2. So then it would be 1 and 1. Okay, when it's frame 2, it would be 2 and 2 and 3 and 3 and 4 and 4. So that would move the cube in a diagonal fashion. So let's try it out. Okay, if I hit edit, if I don't know what's going on, I would see that the expression is invalid after the edit. Sometimes this is an error message. So sometimes the error message is more than 1 line. So it would be good to click on this script editor, and you would see that indeed that error message spanned 3 lines, which is // in Mel language and Maya's expression language. Doubles that is equivalent to a comment. So that's not run. So whatever statement that was run was the expression statement, and this statement is coming from whatever I typed. So in expression language, if I want to use multi-line, we need to terminate every line with a colon, or is that called a semicolon? Okay, yeah, I'm very bad at this. So it's this sign, which is a dot and a comma. Okay, so once I've done that, it's fine when you're just doing 1 line and Maya doesn't mind. But when you have multi-line, you must have a semicolon that separates each line. So Maya is actually looking out for the semicolon. So actually, I could put 2 lines like that. And okay, so let's do edit, and now the result is expression 1, which it has updated the expression. So each expression actually is an object, is a node in Maya that actually has a name. So it's, in our case, it's called expression 1, and Maya has updated expression 1 without an error. So it's the same thing if we did this and then we edit. Okay, you can see that it gives us the same result. So I'm going to close this and step through. Okay, going from a more frontal view, you can see that now it's doing two things. At every frame, it's updating X and Y. Okay, so I don't think you would have a problem with that. So I could actually further go on to do Z, and I could do rotate Y, rotate X, and rotate Z as well. So as many channels as we want from one value if we want to. So I'm going to take that away and update it. So that last value was 5. Now let's put it back to 0. Okay, so that's the most basic thing you can do with an expression. I'm going to comment out this line. So we'll have an expression that has no executable statements. Okay, so let's add it. Okay, so when you run this, okay, you can see that the purple color is gone, so let's put it back to 0 first. So I'm going to do some animation on Z. So in 10, let's move it to -3, and then at 30, let's move Z to 1. Okay, so I'm going to scrub the timeline. So that's how my Z, translate Z attribute is going to behave. Okay, and it's going to be red because I'm setting keyframes. So now we can comment this out, so and sort of put in another temporary experiment. So we can say that translate X is equals to translate Z. Again, we have multiple lines, so we want to terminate each line with a semicolon. So when we do edit, you can see that now there is an executable line that can be executed. So the purple color is back. Okay, and now when I step through, you can see that this X is taking exactly the same value from Z. Okay, so whatever translate Z has, it could be another expression. It could be listening out through connection editor to another object's translate or another object's rotation. That value would get passed down and evaluated by the expression that we have put into translate X. Okay? What we get is it's moving in Z as well as in X. Okay, so let's step it through again. Okay, so when Z increases, X will also increase. When Z decreases, X will also decrease. So that actually ends up in a diagonal line like that. Okay, so I'm gonna put it away again. So again, I comment it out so it doesn't get executed, but let's bring back our translate X equals to frame. So edit, and then when you play again, okay, this time it's doing something strange. That's because translate Z has keyframed animation. So whatever it was doing front and back, now we add a translate X, so it still does the front and back, but then it's moving in X positive all the time. Okay. So the good thing about expressions is that if it's looking up and is using a frame value, as long as the frame value is increasing and keep going forward, our object will indefinitely, until the end of the timeline, will keep going forward. So it sort of saves you from having to put manual keyframes or put a keyframe at the end and let Maya do the interpolation. Okay, so the next, I'm gonna delete this for now. delete selected. Okay, and I'm going to take this away. So the next form, and of course don't forget to update. The next form that you can do is changing that value. So now it's a one-to-one relationship, right? Frame 1 would give you 1 unit. What if we want to start this cube here? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 12 units in our home grid. So if I want to start that off in 12 units, what we can do is we take this frame. Our frame is always starting at 1, so we want to do frame minus 12. So when we update this, on the first frame, frame would be 1, but then we're subtracting 12 from that frame. So on the first frame, it results in 11, negative 11. So it starts at negative 11 units away from the origin. So we could do 13 just to make it negative 12. Now when we play, sort of starts whatever frame number it is in our current frame, it always offsets it by 13 units. So that's how we could do offsets like that. So with the connection editor, as we shown just now, we cannot do. Okay, let's say I want to. We cannot do a -1 or an offset like what we're doing now. So connection editor will take, let's say, X and then put it to translate Z, and then Z would have exactly the same value, but it will be exactly that same value. You cannot multiply it, you cannot add an offset to it, and you cannot subtract a value to it. Okay, so that's the limitation of connection editor. So disconnect, I'm gonna set it back to 0. Okay, so what else can we do with expressions? The next thing we can do is suppose that it's still going too fast at 27, 28 frames. It went out of our viewport, so we actually want to slow it down. So what we can do is we can do frame divided by 2. So this is the division symbol in expressions. So when you hit edit, okay, you can see that because we took away our -13, so it starts from 0 again, and then this time it's divided by 2. So let's run it. You can see that at frame 31, it is still within our viewport, and the distance is halved compared to when we started from -13. So if we want to make it really, doubly slow, we can do a divided by 4, edit to update, rewind and play, and you can see now it's really slow. And you can see that because it's divided by 4, when frame is 1, divided by 4 is a quarter, which is 0.25, and then when the frame is 2, it's divided by 4, you get 0.5 units of movement, so on and so forth. Okay, so that's the other thing that we can do. We can slow it down. So can we speed it up? We can definitely speed it up by doing a multiplication. So if you multiply it by 4, you would see that in frame 1 it's already 4 units, because 1 times 4. So the next frame, at frame 2, it would already be 8, and then 12 and 16 and so on. So in 4 frames it's like gone. Okay, so you can do a times 2. So in like 8 frames it'll be gone. 6, 7, 8, 9, 10. So it's gone. So that's what you can do with expressions. So the next thing that we can actually do is we can do a negative number. So whenever we put a negative in front and we hit edit, what it's going to do is let's take away the times 2 first, so it's easy for us. So when its frame is 1, it's going to be negative 1. When frame is 2, what we had was direct copying of that number. So when our frame number is always increasing in positive, it increases in positive, but now it's decreasing and that number becomes a negative number and gets bigger and bigger, therefore it's going backwards. Okay, so we can do a backwards number and then divide it by 3, and it goes backward in a slower fashion, 3 times slower than the frame number that's increasing. Okay, and instead of and on top of that, we can still have our offset. So now we're trying to combine the methods that we have been exploring with. So if you remember mathematics, you can have priority of the evaluation of values by doing brackets. So we can do frame number with an offset. Okay, let's just do positive numbers first. So let's say we want to start with frame minus 13, and we want to start it with here at frame 1. Okay, so we started with this one. So you add it, and on the frame 1, it's actually minus 13 units, which ends up at minus 12 units. And then you wanted to move, so now it's moving 1:1. Okay, one frame it moves 1 unit. Now you wanted to have this starting point, the relationship of the frame offset, but you want to do it slower. What you want to do is frame 13, and then you divide it by divided by like 2, so that's twice as slow. So you can see, because it's dividing by 2, it's moving slower, but on frame 1 you're not getting 12 units, so you may want to increase that to 26, and then you get exactly the same, well, not exactly, so 25 maybe. If you really want to be precise, you can do the math yourself by bringing up a calculator and seeing what value comes out, but usually just interactively changing your value and will get you that reading here. Okay, so now you can see that it starts with negative 12 and divide by 2. You can get half that speed with an offset. Okay, so with that bracket, the priority of evaluation is frame 1 minus 25 would be okay, so 1 minus 25, it gives me 24, and then it does a divide by 2, which gave me a negative 12. So this is to show you that the priority of execution actually follows our mathematical rules as well. When you're using Maya, you probably is visually driven and not mathematically accurate. Now I'm just trying to show you when your expressions get complicated, sometimes it doesn't give you the value 1 that you're looking for or you were expecting. Take a look at the order of evaluation. Okay, so now what we can do is different expressions for different attributes. You can have each one expression can have many attributes being driven by different expressions at the same time. So some people like to do edit that's just one expression, and then translate y. I'm going to be controlled by another expression. Okay, equals to 2, for example, and then create. You can see that now it's expression 2, and there are 2 different expressions driving 2 different attributes. If I go to filter by expression names, I'll see all the expressions existing in my Maya scene, and I can sort of scroll through them like that instead of showing the expression of the currently selected object. Okay, but most of the time I use the first one, and so you can see that when I go to different attributes, it showed me different expression objects. So most of the time when I'm doing expressions for just the same object, I tend to keep them in one expression. So I'm going to copy this for translate y. I'm going to delete that expression. Okay, so then it's gone, but I've copied the text. So I'm going back to translate x, and I'm going to paste that translate y expression equals to 2, add it, and you can see now that I'm still in the same expression 1, but I've sort of included another attribute into my second line. So one expression can drive like hundreds of different attributes if we want to, but usually for when it concerns another object, maybe another cube, I would keep that as a separate expression, unless for readability's sake, maybe from one value you get the result of another value, and then another value you drive like 5 different objects. Maybe you want to keep them in the same expression because they're all sort of related. Okay, this is getting confusing, right? Okay, so let's just do frame. Okay, minus 13, so it starts at the beginning, and y is 0. Okay, and we can do a rotate x. Okay, just follow the capitalization. Rotate x equals to, I'm going to introduce another variable which Maya understands. It's called time. Hit edit first. Okay, and then now you can see that it's driving the second attribute as well. So time actually is counting in seconds. Depending on how you're setting your scene up in Maya, okay, film is 24 frames per second. So when it reaches 24 frames, actually 1 second has passed. So time, if we're using time to drive a rotate, then at 24, time is equals to 1. That's because we're using 24 frames. If we're using 25 frames, in 25, for every 25 frame, time increases by 1. Okay, if I'm doing 60 frames per second, for every 60 frames, time is equal to 1. So generally, time is slower than, if we use time, it's going to be slower than frame. Okay, so frame increments by 1 every frame increase, but time increments by 1 every 24 frames for film, 25 frames for PAL, 30 frames for NTSC, so on and so forth. So with this, we get very different increment rates. So by 24, because I'm doing film, my rotate x has only rotated 1 degree. Okay, so actually this frame variable is moving too fast, right? So I'm going to use time. Okay, and you can see that now it's moving very slowly. That's because it's only adding 1 to time every 24 frames. Okay, so maybe we want to speed it up, so let's do a, remember we want to evaluate that offset first, and then we multiply it by maybe twice. Okay, or maybe we actually want to multiply by 2 before we do our subtraction. Okay, so that's more like what we want. So again, there's no hard and fast, but just be aware of the order of evaluation. So okay, times 2. If it's too slow, let's double that, times 4. Okay, so it's ever increasing, and then rotate x is increasing the same rate without the times 4. So it's very, very slowly, and when we're dealing with angle, we only see a change when there's like 5 degrees or 8 degrees. That's going to do times 10. So now when I play, you can, the value now is 29. Okay, on the first one is 0.4. As we step through, the value increases much faster, so we have a perceptible change in our angle. Okay, if we want it to be even faster, we can do a 20 degree times 20. So okay, so that's 2 different expressions taking time into consideration, but I could also take rotation x equals to whatever translate x is, okay, and times 2. Okay, so it's going to evaluate translate x anyway, and then just take the translation and do a times 2. So then when we step through, okay, I'm going to times like 10. With expressions, we can do a lot of other things. We could have another transform, another group this cube under another group, and then spin that, affect the rotation in another direction. You can get very complicated and sophisticated motion just from expressions. Thanks for watching. I'm Patrick, and I'll see you again next time.